Hey everyone, this is Rasha again, and I'm continuing the webinar that I gave for considerations for Tableau server uh, and deploying high availability disaster recovery topologies uh, for your server in Tableau. So part of what we discussed in the last webinar was how to configure Tableau server that is fast, scalable, highly available, and has a disaster recovery orientation, right? And that will perform and support additional load and additional concurrency and additional number of users that come, right? We ended by addressing some of the common questions about performance that you're seeing on the screen right now. However, I want to go back a little bit to begin again from disaster recovery. We kind of went through the last 4 slides in about 5 or 6 minutes in the last webinar, so I want to recover some of those slides and then move on to security and also look at a couple of scenarios that I have on server topologies, right? So let's go back here about disaster recovery scenarios. A couple of things that every IT infrastructure shop will ask is to the business is what is the recovery point objective or the recovery time objective? In other words, what's the pain threshold? What is the pain you're willing to take? What is the amount of data loss that is acceptable to you in terms of days or weeks, or in terms of even hours? At which point you would have to take your backups at a frequency of hours, regular frequency of hours, regular interval of hours, or or what is the downtime uptown scenario that is acceptable to you, right? So if the server, if there was a disaster, um, how much time would be okay before we can bring up the entire environment so that the organization can start functioning back again, right? So any conversation of disaster recovery requires these two basic inputs in order to devise a strategy. And now a low recovery point, or low RPO, low RTO strategy would be really an expensive one because you would have to have a hot standby replica of your data center, right? You'd have to have a hot data center. You'd have to have the hardware, software, and data all set up um, on a weekly basis or an hourly basis or a daily basis. It's being replicated so that your organization can start functioning very quickly. Uh, if you go for a medium RPO RTO strategy, that's going to be only moderately expensive. And here the question arises of what kind of disaster recovery data center do you want, right? Do you want a hot data center as opposed to a warm or a cold or even a lukewarm one where there is, hardware set up in the data center plus software set up and maybe even a little bit of data. So you have this kind of lukewarm setup, uh, and then you can have a high RPO RTO where the threshold is very high and you allow for failures. And you can do it yourself. Really, it's much higher threshold of pain there, right? Now, so this basically informs your overall DR strategy, and that is important to know, right? So basically in Tableau, the DR options that you have are pretty similar to any other business intelligence product that you might be using, like Cognos, MicroStrategy, or even ClickView, right? So the basic idea is to take a backup and restore that backup in at the time of disaster, right? So Tableau provides native backup recovery functionality through the tab admin commands that it has. And you can create a script which will perform the backups every week or every day or every few hours as you desire, right? And these backups are really a snapshot in time. They're really archiving your Postgres embedded database in Tableau and .tde, the Tableau data extract zip files, right? So they are columnar data stores of Tableau, as we've already talked about. And you can basically archive this backup either on the SAN on, or you could ship it to another data center or put it into another machine. So really what you're doing is taking a backup and restoring it, right? So this is very similar to any other product that you may have. The only difference is right now in Tableau, this disaster recovery option are command line options, and there is a there is a need to push this kind of functionality on the uh, on the web admin console, or create some kind of on the web admin console that Tableau has, so that you can just schedule it there, and it would happen at the requested interval of time. The backup would happen there, right? The other strategy of doing any kind of disaster recovery would be just to take a clone of your data drive, just to basically uh, have a copy of the data drive that you have. And in Premiere, we do both, right? So we have a combination of taking a backup at every night 2 p.m. And then also we do cloning of our data drive, so we are doubly covered from that standpoint. Planning for load. So this is an interesting concept, right? So we talk about disaster recovery, and we talk about high availability. Inevitably, any robust environment requires us to plan for additional load, for additional concurrency, etc. Right? So uh, we need to understand Tableau server components from the perspective of which processes in Tableau are generating load. Right? So we know this. We know that the backgrounder, the WSQL, and the data servers and the data engines are all big load generators, depending on the type of activity you are doing. Right? If the number of concurrent users is very high, even in login time, right, it'll basically use a lot of WG server processes. Albeit these processes are not heavy by any means, but if you have a very high concurrency, even this can require additional processes to be run on each server, or additional servers for that matter, right, in a distributed environment, additional workers. Uh, the number of users is critical to understand the concurrency, and also understand the load that is going to be generated by interactions with your WSQL. Right? Backgrounder is going to generate a lot of background processes, which are actually really heavy. Right? So you want to be cognizant of how many backgrounder processes you are running in terms of backups and restores, what time you're running them, right? In terms of extracts, Tableau data extracts. And then you have things like the data engine, which are basically serving as a database server. So they're really serving as a database engine, and therefore a very core aware process. And you need to basically understand what kind of load you have in terms of Tableau data extracts, because that can affect the topology of the server that you're trying to deploy. Inevitably, when we talk about load, one of the big conversations is about concurrency, and everybody has a different, but also sometimes overlapping definition of what is concurrency, right? So concurrency can imply a number of different things. The number of people that are logging into the server at the same time. Again, that's a WG server process, as we know, the app server process. How many people are interacting with the visualizations, and that's a WSQL process. How many refresh extracts are occurring in the back end, and that's a backgrounder process. How many publishes are happening, and that involves both the data server and potentially data engine processes. So all of these things imply concurrency. What you need to understand from your perspective, from your usage perspective, is what kind of usage profile do you have in your environment? Is your environment a Tableau data extract heavy environment, or Tableau data extract light? Is it publisher heavy? Are there a lot of Tableau desktops from which content is being published to the Tableau server, right? And are there a lot of consumers or just interactors of your data? Or do you have a scenario where all three of these things are very heavy in your environment? So that is going to affect and influence, apart from your DR strategy. Apart from your DR strategy, that is going to influence the load, and therefore the topology you will select for deploying your servers. Right? And then the most important consideration of all, perhaps, is an SLA, a service level agreement. What is the service level agreement that you have with your business, right? In Premiere, for our dashboards, we'll use a service level agreement of 3 to 5 seconds, right? And this is potentially a very, very aggressive service level agreement. And although for Tableau we have not pre-established that, if you have that kind of aggressive service level agreement, then you need to basically provide for it, right? So let's look at considerations for performance and stability, right? So we've talked about understanding your load. So we know that performance and scalability in Tableau are affected by a number of different considerations, whether you want a highly available and distributed disaster recovery oriented environment, what are your SLAs for your dashboard. We've talked a lot about processes that generate load and what is the usage profile of your environment, right? So Tableau does not really provide a specification in terms of how to configure these kind of environments. It does have specifications for what is a small environment, what's a medium environment, what's a large environment, and it has just this very generic specifications. But it's very important to be very precise about how you understand your environment and therefore deploy according to that measurement. You design and deploy an environment according to that measurement, right? So uh, Tableau's capacity calculator, which is based for small, very small, medium, and large, and very large environments, has a VisQL bias. It has a bias in terms of the number of VisQL processes that you're going to run in your environment. VisQL processes, we know, is CPU bound, it's RAM hungry, it's a high affinity process, right? And so, with this kind of a process, uh, have uh, you have to be um, a high RAM environment, right? So one of the specifications that Tableau always gives is one of the rules of thumb is always specifies it that you must have an 8 GB per core in your environment. So if you have an 8 core environment, then you should have a 64 gig RAM. If you have a 16 core environment, which is distributed between worker one and worker two, then you should have 64 gig RAM on each of the two servers, right? You need to also additionally, as we have seen, plan for your Tableau data extracts, right? So plan for backgrounder and the data engine, which is a very core aware process because it is the database engine as Tableau. And so sometimes potentially you could do a separate machine, a separate worker, which only runs the backgrounder, a backgrounder only worker node, if you will. And what is most important when you're considering high performance and high scalability is the uh, ability to add more resources to your server, right? So you need to plan for growth, and for that you need to define some utilization thresholds for your memory in terms of RAM and hard disk, and also for your CPU utilization. And there are a number of different tools that are available for this, and I do recommend that you research this. In Premiere, we use Perfmon, a performance monitor, for monitoring how the CPU utilization is and the memory utilization is for our servers. But it is important to measure how your server is being utilized. Tableau itself will only give you how the Tableau server processes are being utilized. It will not tell you whether these server processes are saturating the CPU because that is essentially monitoring the CPU. So monitoring CPU and memory additionally is very important so that you can plan for growth, so that you can add additional resources. So what are some of the common questions about performance that we encounter? And I think perhaps the most common one is why do we need a physical server? Why can't we go with VMware? Most infrastructure shops in IT will basically insist on VMware. And we've noticed that we run VMware ourselves, that VMware works fine as long as you are not over allocating memory. Now, This is over allocating of memory and CPU is a pretty common problem that we see in all IT shops, and it's a big it's a problem that can be easily solved, right? I mean, you can keep your min max at about 80s. I mean, you know, min max at an even ratio, or you can, in other words, you can make your min and max equal to each other, and that way you will never have over allocation of memory. And if you were to define different types of min max, I would say 0.75 is to 1 ratio for min and max would be good enough. Anything lower than that can potentially go into memory over allocation. A lot of environments also do virtual CPUs. So that I insist you basically set your min and max equal to each other. No differential allocation for them. Right? So for Tableau data extracts, a common question is about whether we should choose an incremental strategy for Tableau data extracts or whether we should do a full refresh. And this is pretty common to any kind of scenario, even in databases or servers, server backups. This is the same question. Should we do a full backup or should we do an incremental backup? Should we do a full load or should we do an incremental load, right? So I would say with Tableau data extracts, if the volume of data that you are incrementally adding to the Tableau data extract is very big, then do a full refresh. If it's small, then do an incremental. It's as simple as that. So you have to see how much time an incremental versus full refresh is taking. Keep in mind that when you are doing an incremental refresh of the data extract or incremental add to the data extract, it has to do a calculation of the diff. You have to do different differential calculation in order to figure out what needs to be added, right? So that in itself sometimes can be pretty heavy with a heavy volume of data. And so full refresh is not as bad as it is sort of infamous for, right? It can be very useful if your volume of data is very big. Solid state drive, right? So high performing disk drives are very important for Tableau data extraction. Any Tableau server, for example, which is involved in backgrounder and data engine processes, could benefit from solid state drives. So I would recommend using solid state drives as we go forward, just because your Tableau data extracts will perform phenomenally well with it. WhiskQL and query cache issues. Now this is a problem, and a lot of people talk about query cache in distributed environment and say, are you persisting your query cache or syncing your query caches or WhiskQL image caches between worker one and worker two in a distributed environment? Right? If you have two workers in your server environment, worker one, worker two, if user one comes in and submits a query to worker one, and that creates a query cache, and then user two comes in and that query is executed on worker two, will it use the same query cache that lives in worker one? Has it been synchronized to worker two? The answer is no right now, right? So image caches and query caches don't synchronize or persist from worker one to worker two. Right now they're getting recreated. Tableau has mentioned about solving this problem in future. So uh, maybe it's Tableau 9, maybe it's Tableau 10 when this issue gets addressed. And I cannot, I mean, I talked about this in the previous slide about system monitoring. System monitoring not is not about just Tableau monitoring on how many users logged into Tableau, or how many Wiz interactions happen during one potential period of 5 minutes in an hour. That's just not the only thing that you need to monitor. You need to monitor the saturation of your hardware capacity. You need to, if you're going to plan for better and more hardware, you need to be able to monitor CPU, memory, and disk saturation, right? So that you can understand whether your thresholds are being violated by the usage in your environment. Right? So these are the most important questions when it comes to, I think, highly available, distributed, disaster recovery oriented architecture that can be fast, high performing, and scalable, right? Let's move on now to some scenarios, right? So this is a typical scenario, large scenario in terms of Tableau server deployment that we are seeing here. And this is a kind of a server topology that we would select if we had 200 concurrent users, right? So you can see here that your primary, which is running your, which is really your, which is really running your licensing process, and therefore it is the primary, has only two cores because they're all light processes, gateway, licensing, and search process, and 8 gigs of RAM because it doesn't require that much, and it's not going to count towards your core licensing. Then you have a backup primary, right, which needs to come up in a highly available environment. It will be brought up manually and it has the same configuration. You have two workers in this environment, so you can see here your gateways are highly available and every single process that you have is also highly available. Right? And then you see that some of the processes we are actually instantiating uh, two processes for each SQL server, two processes for app server, two processes for data server. Right? Everything else has one process running on the servers. 8 core, 64 gigabyte, and this is ideal for 200 concurrent users, unless you have a Tableau data extract heavy environment. And in this scenario, we are taking into consideration a very heavy Tableau data extract environment. And so what we have is actually a 24 core deployment where the third worker here is only running the backgrounder process. It's running 6 backgrounder processes. It has 8 core and 64 gigabytes of RAM. So this is going to be a heavy duty Tableau data extract server where you have hundreds of data extracts that are being performed at different times of the day, right? And so this would work very well. It's really a 5 node architecture with a load balancer acting as node 1, primary, node 2, worker 1, worker 2, node 3, and 4, and 5 right there, right? So let's get on to security, right? WG application server in conjunction with the repository are in the business of managing this, right? This function in Tableau. And whenever we talk about security, we talk about a couple of things. One is authentication and the other is authorization. Authentication is a process by which Tableau server understands if you are the one who you are claiming to be uh, and validate that. And authorization is a process by which Tableau server validates if you are authorized to perform a certain action or to see some kind of data, right? And authentication plus authorization is equal to access to content or access to manipulate content. Now, we're not going to talk a lot about authentication, but I will mention in passing that Tableau natively authenticates through Active Directory. It does not support other authentication engines like TAM or OpenAM. But Tableau does support something called SAML, right? Which is an industry standard protocol for authentication, right? For inbound SSO and for single sign-ons. And through SAML, therefore, Tableau can basically utilize both TAM and OpenAM and any other authentication engine. When it comes to permissions or capabilities, Tableau does things a little bit differently than, for example, MicroStrategy or Cognos, right? So in Tableau, lower trumps higher. In other words, if you look at this diagram, a Tableau web server contains many websites, which contain many projects, which contain many workbooks, and each workbook contains many views or worksheets, right? So if, for example, you were denying access to somebody at a workbook level, but granted them access to a worksheet in a workbook, then that user will automatically get access to that worksheet, even if you have denied them access to the workbook. Now, this is a little bit counterintuitive. You denied them rights on the parent, but gave them rights on the children. and the children, the rights given on the children will still persist. They will still get a grant on the child, but deny on the parent. So they will be able to go into the workbook and see that specific view, right? So Tableau does this implicit thing, as opposed to other business intelligence software where you have to grant at each specific level, which can be a little cumbersome. So Tableau is a little more savvy about how this process works, right? So I've put in some scenarios here, and the typical scenario is, has the user been specifically denied a capability? And that's a lower level, right? A user is a part of a user group. So if the user has been denied that capability, then they will not be able to perform that capability even if the group has been allowed that capability, right? So the user has been denied the capability, then the user is denied. If the user has not been denied the capability and the user is part of the group that is allowed that capability, then the user is allowed, right, etc., etc. So you can go through that chart and figure out how it works. Now let's go into the server layout, right? We talked about the fact that each Tableau server has multiple sites. This is how Tableau uh, enables multi-tenancy or multi-customer environment. So if you have a server which is basically serving multiple customers, they each can have their own site. And on each of these websites in Tableau Server, you can have a project, and a project will have the workbooks that the users publish or Tableau Desktop users publish, and the workbooks will have views in them. And each Tableau website also has user groups, and each user group has users, right? Because these user groups are used for security, for management of user rights, right? So we understand that permissions can be granted at on the site at a user or a group level, and permissions are granted for visualization containers like projects, workbooks, and views. So each project is just a collection of workbooks, and each workbook is a collection of views. Right? So take a look at this diagram. This is scenario one, and you see how a user who's a part of a group, the group has been denied access to a project. But user, a specific user A, has been, his group may have been denied, but he or she has been allowed access to the worksheets or views in Tableau. What happens in this case? Well, the user is granted access to the view because the lower trumps the higher. So the user being given that right trumps the group being denied the right. So that's scenario one to consider, right? Really, the lower level wins, right? So, what's the key takeaway here? One of the things when we understand this basic concept in Tableau about lower denying higher uh, is that the key takeaway here is make sure that you assign your permissions at a group and a project level, that you don't go and nickel and dime your entire permissions and set it on users and specific views and workbooks. Your user management is going to be really tough and difficult. You don't want to do that. Right? So make sure you do that, right? The second thing that you want to remember here is that publishers rule, right? So publisher, any you can do a lockdown of an environment completely, as you can see in this diagram. You are denying marketing department rights on the project, and that means they don't have rights on workbooks or views because you've never granted them rights. And then comes a publisher who publishes a view and provides a couple of users in marketing department access to some of the views in their workbook. Well, what happens then? Publishers rule. Them granting the access to the user will override any deny you have on the marketing department because of the lockdown, right? So remember that second rule that we have here, right? These are a set of different capabilities that you have, and uh, you want to be aware of. Project leader will be project admin. I mean, these are some ways of how you designate your users into user types. Who's the data source editor? who is creating projects, who's creating data sources, and then other workbook data source rights. Right. Again, some of the definitions that we have just enlisted here for you um, that you want to be aware of. And now we'll take up scenario 3. And again, you remember our rule, the lower trumps the higher. And here, the user and the group have been denied access at the project level, but the user has been granted access at the view. And so the user will not only get access to that view, but will also inherit access to the data source to which that view is connecting. Data source being your ODBC connection. Right? So you can basically govern access at all of these 4 levels. Right? So you're granted access. Now let's look at this. And again, here the group has been granted access because even in spite of being denied at the project level, the group was given access to the view, and therefore you have a grant on the view. And you inherit the access to the data source. Now, the best thing to do would be either to set this security at a workbook or a project level, as we said. And here you can see the user and the group have been granted access, but that specific user has been denied access at the workbook level. So what happens to that user? The lower trumps the higher, even if the group to which he has been a part of has been granted access to the project and the workbooks, he or she has been denied that access. And therefore, they will lose access to that workbook. So this is really important to know. I do want to mention that I've consulted a lot of Tableau white papers and presentations for this. So I'm very grateful to Tableau, to our OEM manager and our sales support architect